Hello, and welcome to Session 1 in our Automotive Electronics Roundtable series, sponsored by Murata. My name is Katie, and I will be your Globalspec moderator, and I would like to review a few housekeeping items with you before we begin. Please take a moment to familiarize yourself with the operation of the user interface for today's webinar. The large window with the heading Presentation in the upper left is the primary window for today's webinar. Just to the right of the main presentation window is the speaker bio window with background information on today's presenters. Just below that is the Q&A window. At any time during the presentation, you can enter a question into the box in the lower section of the window and click Submit. Your question will be placed in the queue to address when we get to the Q&A session. At the bottom of your screen, you will see additional buttons to enhance your webinar experience. To see what a particular button does, just place your mouse pointer over it and a tooltip will appear with a description of the button's function. Now I would like to introduce our moderator for the Automotive Electronics Roundtable series, Edgar Sauter. Edgar is the Senior Director of New Product Technology at CSA Group. His team looks into the technology horizon for new developments and applications that could present opportunities for CSA's test, inspection, and certification business. To read more about Edgar today, please look at the speaker bio window right next to the main presentation window. And now I would like to pass things along to Edgar to lead us through today's discussion on the roles and technologies behind ADAS. Edgar, welcome to today's event.
Thank you, Katie, for the introduction. I am Edgar Sauter, Senior Director of New Product Technology for CSA Group, and I will be your moderator today. We are very pleased to have you here today as we bring together this excellent group of experts and engineers in the automotive industry to talk about a subject that is reshaping transportation at a disruptive pace. Today, with us, we have Peter Els, who spent 15 years working as an engineer in South Africa's automotive industry, and now he writes about the subject for different publications. We have Warren Smith, Director of Perception for Insight LiDAR. So Warren brings a wealth of sensing and processing knowledge and experience to the table. We have Matt Sutton, an independent consultant with 20 years of global professional automotive engineering experience with stints at Ford, Jaguar, Lotus, and Rolls-Royce. And we have Nitin Narayanan, Senior Manager of Mobility Solutions for Murata. Nitin has an extensive experience dealing with OEMs and Tier 1 suppliers for safety and autonomous technologies. So Peter, Warren, Nathan, and Matt, thank you very much for being here today with us, exchanging your experiences, opinions, and ideas with the audience. Now, increasingly, automobiles are now using more high-tech features to improve driver alert, passenger safety, and the whole driving experience. These advanced driver assistance systems, or ADAS as they are also known, are a remarkable shift in automotive experience. Today, we will talk about the technologies behind ADAS and, of course, the features that we expect to see in the future. So before we start talking and exchanging ideas, let's take a short moment to thank our sponsors. So Murata is a worldwide leader in the design, manufacture, and sales of electronic components, sensors, Wi-Fi and Bluetooth modules, communication components, power supply modules for the mobility market. Murata is an established leader, innovator, and key contributor in driving advancements that help shape the future of the industry. They continue to pave the way by fueling the evolution of the mobility experience. The future of mobility relies on technology. That technology relies on Murata. For more information, visit murata.com. This webinar is hosted by Globalspec, the world's largest online engineer destination for product sourcing and information. So without further delay, let's start with our conversation today, with our panel. And the first topic is the challenges that ADAS are facing today, that those technologies are facing today. So to start, I would like to hear from you an idea, what are those technologies that are supporting ADAS now?
Thanks, Edgar. Thanks for the introduction. Happy to be here. So, if you look at some of the ADAS technologies today, I think automatic emergency braking is one. It's been around for a number of years. Blind spot detection, surround sensing, and then some newer technologies in terms of lane departure or traffic sign recognition, pedestrian detection. So there's been some evolution, and not all of these technologies are available in all of the cars. Some of them are only more prevalent in the consumer lower end consumer cars, whereas others are available in the high end cars as well. So.
Right, and have you seen, for example, Peter, in your for the articles that you have write and your experience from these technologies that Nathan mentioned, what are those like more prevalent now, and probably that have to do with sensing, LiDAR, etc.
Well, I think it depends very much on the level of ADAS that we're talking about. If we're talking about autonomous emergency braking, then radar is really important. There's certain suites or certain sensors that are better suited to certain functions, but cameras are I think they're probably the most pervasive of all sensors. I don't think there are any systems that really run without a camera. I think the industry consensus is that the higher levels of ADAS, moving into sort of level 3 and definitely the autonomous driving vehicles, LiDAR seems to be a given. There are some people that are saying LiDAR is a fool's destination. Mr. Musk being one of them, who's going a different path to the rest of the industry. But yes, I think cameras are given, ultrasonic sensors for close proximity, and then radar is obviously millimeter radar is almost you can't do without it either. So full sensor suite depending on what you need.
Yeah, I think. Sorry.
Go ahead. Sorry.
I was just going to say, I think that a lot of people's first real taste, if you like, of autonomous driving would have been the sort of stop-start cruise control, and obviously the suite of technologies that have advanced since then. But I think a lot of people that have been used to that sort of level of ADAS, the future's looking quite bright, really, in terms of, as you say, with millimeter radar, etc.
Now, it brings another question, because you guys are talking about ADAS and automation. Is there any difference between ADAS and autonomy when we are talking about automobiles?
Absolutely. There are good technical definitions to distinguish these. From a practical standpoint and from a user standpoint, I think the key difference is who is responsible. So in ADAS, the human driver is responsible and may be assisted by the robot. In autonomous driving, the robot is responsible and may be occasionally assisted by the human.
Got it. That's an interesting point, Warren. Thank you. Now, before, probably the audience doesn't know this, but when we were preparing before the panel, we were chatting about autonomous driving, and Warren and Nathan were telling us all this experience that they had driving autonomous cars. So, a quick question today. Based on ADAS and autonomy, today, what is the actual level where we are that people can actually acquire cars or being able to drive cars on the street?
Yeah, I think today we're more, if you look at the SAE levels of autonomy, so we're probably between level 0 and level 2 plus. I think a lot of the OEMs are looking to level 2 plus. The GM and Ford and the Super Cruise or Blue Cruise. So that's kind of where we are today. And of course, we talked about robotaxis, which are more level 4 today. They do have a safety driver in there. So I think looking at it from the OEM perspective, I think they're taking a hybrid approach. So basically, they have L2 systems, but then also invested in L4. Yeah.
Right.
And to just translate that into layman's terms, right? I think exactly what Nathan said. I completely agree. Is that the state of ADAS, the state of robot assistance in cars, is that you as the human driver are still responsible, and this is kind of the defining characteristic of the current state of the art. And nothing that you're buying on the market should you trust to be responsible for your driving.
I think it's quite a big ethical question. Sorry, just a big ethical question, isn't there? Between the trust, as it were, of a human being handed over to a machine. There's a lot of people out there that, at the moment, I think it's a very difficult concept for people to understand that you could actually do that and accept. Very difficult to accept for some people.
Well, I also, sorry, Matt. I also think I fully agree with you. It's almost an ethical question. I mean, if we go back to Ford's aims or goals on self-driving, if we go back to 2017, I think it was when Fields was still CEO, Ford was planning to have a fleet of autonomous vehicles, self-driving autonomous vehicles on the road by 2020. But during their own experiments, during their own testing, not lay people, but engineers actually fell asleep behind the wheel of the car because the car was so good at driving itself. And at that point in time, Fields actually said, look, we think we're going to skip this level 3 completely. You know, we go from level 2, which is a definite driver assist, to a level 4. We take out that intermediate because we know practically people become very trusting in the system. So whatever the fine print says, you must be prepared to take control. We're dealing with humans, and humans tend to text and drive.
You know what, Peter? You have a really good point. Like I remember, I think when we all had to do our driving test, you know, that shoulder check, and when we were doing reverse to look at the back of the mirror. Now with this little camera that I have, I totally forgot to look back on my although the camera tells you this is not replacement for you looking behind it. And also I have these little 2 sensors that alert me if someone is walking by. And one day, I suddenly crashed because I forgot that. I was carrying something in the back of my truck, and it was blocking the sensor, I guess, and didn't detect the person. I almost crashed with someone. So that's along the line of how easy it would be to for actual drivers to deal and interact with this type of technology, and how that transition would be. Of humans actually learning that, they cannot lose those skills.
That's a very big question, isn't it? Because I think the skills, if you don't practice them, of actually being aware of your surroundings and what's going on, if you're not regularly practicing those, and you know you're doing a lot of, say, highway driving, etc., you soon forget. I really do think you soon forget. But you know the problem of the handover time between the autonomous and the human driver, if that's very short, then, you know, as the speeds increase, then I think there's possibly quite a large danger present there.
Well, I see that there's a fair amount of conversation around exactly what you're talking about, Matt, where there is a point being made that maybe we should introduce a separate test when it comes to your driver's license to be able to actually engage with a level 3 vehicle. So I support what you're saying.
Yeah, I think I agree with Peter and Matt. So there should be more awareness when the driver is in the car as to what features are available, what are the limitations. So they don't tend to use a feature that's not meant for automated driving, for self-driving, and take their hands off the steering wheel. So I think that's very critical.
But then, Nathan, does it not also come down to standardization? You know, I mean, we've all been on road shows. You know, where you for a week you're flying into an airport, you get a hire vehicle, you drive out, you get to your venue, and you go. Now, if if OEM X has got autonomous emergency braking and he doesn't have forward collision avoidance warning, and OEM Z has got both, you're not going to have time to read the manual. You get into the car and you've just gotten out of a car that's got both warning and the actual braking, and you get into a car that doesn't have the warning. It's just got the braking. The two vehicles operate completely differently, but they are still ADAS, and they would still probably be, depending on what the suite is, they would still be a level 2. So from a consumer's point of view, you're going to be confused, and that's not going to be good for your confidence. What do you think, Warren?
There's this hilarious, I mean, in an abstract, right, a little bit of a hilarious dynamic going on where, the human is driving, he was responsible for all driving behaviors. And then we realize, hey, look, humans are really bad. For example, they don't see behind themselves really well. So we try to put in a turning camera, we put in blind spot detection, we do all this stuff. And then humans learn to trust it. Of course we do. That's why it's there, right? That's what it was sold to me for. That's what I paid the extra $1,000 for. And then we say, well, humans are becoming too complacent. So now we're going to install a new system that monitors the human to make sure the human is monitoring the system that I just paid $1,000 for to maintain, right?
It's true.
And there's this problem, right, where the human and the robot are blaming each other for every last little problem, right? And the responsibility really has to be on the engineers and the product builders to educate, to build a product that is intuitive and understandable without reading a 100-page manual, right? You should be really careful about how you name it, how you market it, right? All of these things, and test it in these kinds of scenarios, right? Like the question you have to test, hey, with a new driver who's not familiar with these, right? Does this improve safety overall? And that's absolutely something that is important. It should happen. Whether or not every OEM out there is doing all of that, a lot of them are, but is up for debate.
If I could just jump in, sorry, Warren, you and Peter both touched upon something which I think is at the root of all of this, and that's the actual SAE classification of ADAS. The 6 levels, for me personally, they just don't feel like enough explanation around each one. And I think giving those 6 levels to the consumer, I think they're going to be even more confused, to be honest with you. And there's a lack of overlap, if you like, in what consumers.
Yes. This is 100% correct, right? Like, here we are experts, right? And the first thing we have to do every time we have this conversation, we have to redefine the levels of autonomy, right? The fact that we as experts have to continue to redefine it every time we have the conversation is evidence of how useless the terminology is, right?
I agree.
I would much rather we define it around what it means for the user, right? What is their level of responsibility? What features does it add for them? What can or can they not do, right? This is the kind of granularity that I think is necessary, maybe for academic papers or some internal product development, right? For safety validation, some of these terms are useful, but for a public forum discussion, these are really just not very useful. And any terminology that you have to redefine every time you use it is just not useful.
It's not a terminology. Yeah, I agree with that for sure.
Yeah, I think, Warren, that was a good point. So I think the SAE levels, I think there's also discussions from a lot of the OEMs that they need to be changed, or there needs to be more detail in terms of like KPIs for different levels of automation or accuracy of distance or corner cases. So those are some of the features that probably need to be better defined in those levels. And one more comment, I think, regarding standardization. I think within the OEMs are seeing that at least they are standardizing some of the hardware across models. So I think that's something we're seeing right now.
That is a good point, and actually, like, that could help us talk about a very important topic just to introduce it, like humans, we have been doing shift in our processes based on technology. Like 100 years ago, we used to have like, I don't know, wood in our houses, burning wood to make our food there inside the houses. Like now that's a kind of a practice that is not common. Now we have our stove. We open the oven and there is a whole gas pipeline coming to us. But that is because we have learned to rely on very safe and secure pieces of technology that they have been proven, tested, and certified. So then the question is, based on what we have talked, how safe and reliable are those components that we use today for ADAS? And Nathan, probably you come from Murata, you have a more idea of the components. So if you could open the conversation there, that would be great.
Yeah, in terms of safety standards, I mean, there are safety standards out there, like the ISO 26262, and it's just different ASIL levels. So I think we started using those. Like Murata, we play in the stability control space, so we are pretty aware of this. But it's also making its way into autonomous driving. So I think safety is pretty important. But in terms of autonomous driving, I mean, safety, to guarantee safety, you need to collect a lot of data and do a lot of testing. So I think that's a big challenge. You need to have big fleets, and I guess many partners, and you need to have the speed and I guess GPUs to handle so much data. So I think that's one of the challenges. So what I'm seeing is in terms of safety, a lot of the players in this space are taking a redundancy approach. So they have completely redundant systems, software. So they're redundant. I mean, that's one approach to address this. Yeah.
I think
I want to point out, like, super big picture, right? I don't know worldwide statistics, but just thinking about the U.S., where I'm more familiar. Automotive safety and the safety processes that we've been following have dramatically improved road safety over many decades. So much so that even though the number of road fatalities today are catastrophically large, it is smaller now. That is, fewer numbers of people die from road accidents today than did during the Model T days, right? 100 years ago, right? When the populations were smaller and there were fewer cars, more quantities of people died on the roads back then than today. And so there is this constant march of progress because these safety standards, because of this relentless push towards safety. And I do think that we're on the cusp of another large step function improvement in this. And any of those road deaths are not acceptable from an engineering standpoint. But if you zoom out really big, things are looking really good.
Marlon, can I just ask though? Sorry, just saying about the big step change. I'm wondering what's going to happen when there's a mix of fully autonomous vehicles and non-fully autonomous vehicles on the road. Do you think we're going to see? Yeah, exactly that, Peter.
Yeah, that's a really good question. And basically almost all of the effort being spent developing self-driving technology today, for L4 robotaxis or trucks or whatever it is, are solving that exact problem, right? If we didn't have that problem, we didn't have humans on the road, we would be solving trains, right? And so you are absolutely correct that this is a huge problem, but it is also the huge problem that people are spending enormous fortunes trying to solve.
But is it not a transition? Are we not on a journey the same as electrification? So with electrification, it's easy. We've got mild hybrid, we've got hybrid, plug-in hybrid, and fully electric battery vehicles on the way to zero emissions. Are we not following a similar route with ADAS to fully self-driving autonomous vehicles, autonomous fully self-driving? So are we not in a transition phase when we're talking about level 2 and level 3, that, as Warren says, maybe in 30 years' time, those vehicles, we will not be building vehicles with ADAS. We will all be sitting in a cruise origin, and it'll be fully self-driving and automated. Is that not where we're heading ultimately?
Yeah, I think, Peter, to your point, I think zero accidents, I guess that's one of the targets. A lot of the companies improve safety, zero accidents. I think I was reading somewhere from the WHO, they say there's 1.3 million fatal accidents per year globally, and 94% of those are human mistakes. So I think that's one of the motivations for this. And also, if you look at the robotaxis, I think mobility for all was one of the other ROIs for that. But then to Matt's point, in terms of how other cars fit in, I think we're seeing activity in that space where the companies are coming up with aftermarket retrofit parts that would bring in the ADAS features to some traditional cars or classic ones.
I think Peter brings up another interesting point as well, right? And that is, hey, we see robot cars as a transition point to something, and we don't exactly know where it ends up. But the question is, how does it transition, right? And there are two broad categories that people imagine. One, for the reasons that we talked about, right? How can you trust the human driver when he's asked to take over 1% of the time, right? Humans, we're just not built for that, right? We're built to try something for an hour and then trust it until it breaks. So because of things like that, there's a real strong push, I think, to say, hey, we have to, we can't incrementally slowly get there piece by piece, taking it away from the human to like 1% to 0.1% to 0.01%. But we really need to make the switch to full responsibility to the robot. I think this is one argument, right, for why L4 has to come first or full robo cars comes first. The other, and I do think there's still a lot of merit to this path, right, is hey, can we incrementally go through ADAS? Now, maybe you could balance both of those. For example, can I buy a car? It's my personally owned vehicle, right? It can't handle everything. It's not going to go from pickup to drop off, but maybe it can handle certain highways, and it can handle those highways in a way that it is fully responsible when I'm on that highway, right? And this is a huge feature. I would love it. I would personally spend thousands of dollars every year if I could go to sleep on the highway, right? But the real limitation here is surprisingly, and this is really surprising for self-driving generally, it's not software. The limitation here is hardware costs. The problem is that current implementations that solve this correctly and with enough reliability, right, the March of Nines, in order to switch over that responsibility is in the 6 digits of US dollars, right, to buy the hardware kit. And so on one side, L4, I think the hard part is the software. So if you solve software, then this is the first thing to go. But boy, if you could solve the hardware problem, I think personally owned vehicles could come first, right?
Yeah,
the stuff like solid state flash LiDAR, is that not going a large way to, specifically if you're going to geofence the vehicle? Would something like flash LiDAR not do away with your 264 Velodyne that costs you $70,000 instead of $70,000? I hear people talking of the hundreds. Are we not moving down that road, Warren? Are we not getting closer to it?
Oh, that's a beautiful question. And I think that there's a possibility, but let me tell you why I'm not terribly hopeful in that direction. So flash LiDAR does use certain benefits, right? So this is potentially solid state, which really here we mean reliable and cheap, right? It can be both reliable and cheap and give high density, both which are necessary to solve this product. I think the problem is that the underlying technology has some unfortunate side effects. For example, it's difficult to get the sensitivity necessary with flash LiDAR just because it's hard to get enough power out without some time multiplexing while being eye safe, which is also a key feature. They also struggle with things like retroreflectors. So there's a lot of blooming around retroreflectors. Basically, like traffic cones look much larger than they are, and this makes it very difficult to drive. They also have troubles with things like multiple returns. Now, I'm not going to explain what all these things are, but basically it means that it's going to have hard time driving around traffic signs, road construction, and bad weather. Now, maybe those problems are solvable, but I don't think anyone has demonstrated the ability to solve that yet. But if they can, right, there is a huge market, there is a huge opportunity for value creation.
Mm-hmm. Yeah, I think, Warren, that's a good point. In terms of LiDAR, so I think eye safety is a big concern for some of the wavelengths. I think 900 nanometer, so it limits the range. I think we are pretty familiar with that because we supply components to limit, I guess, to narrow the light pulses for that. So I think the higher wavelengths are more popular now and different technologies. But then I think you mentioned highway driving, so there's also a trade-off between the distance and the reflectivity, right? What distance you can measure it up to, and I guess what kind of objects you can detect at that distance. So when you're going at higher speeds, you want to detect longer distances.
I do want to say that I think, although I wouldn't necessarily put all of my eggs in flash LiDAR, it certainly hasn't solved it already. Maybe it could one day, I don't know. I do want to say that one reason for optimism that this can be solved with hardware is that LiDAR is still a very, when we look at the broad scheme of technologies, LiDAR is still pretty new, right? It's still pretty young. And when you think of, when radar was only 10 years old, right? It covered the entire coast of England, right? And it could only see entire German air forces, right? That's the kind of resolution they were going for. And LiDAR still is early in its journey, and I expect, hope maybe people listening to this right now, right, will have ideas to be able to revolutionize LiDAR and absolutely make it both higher performing and lower cost, which is 100% possible with new, young, immature technology.
Now, this is a good point, and I would like to move to new technologies. I have a couple of questions for Matthew and Warren about that. But before we jump, we've been discussing about, say, the reliability and safety of technology. What about how is the government helping? Like, are the governments on board? Have you heard about regulations? Like, how is that supporting the development of ADAS, as far as you know?
Yeah, I think just some quick comments on that. So I think in EU, Japan, and China, they have some standards for L3 with some constraints. And I was recently reading that in Germany, they approved level 4 for as soon as 2022 for automatic valet parking and shuttles. So there's some regulations coming along, but I think in North America or the US, there's not been anything recently. They launched the infrastructure bill, but there's nothing relevant to autonomous driving in there. Go ahead. Yeah.
Oh, please, I didn't mean to interrupt.
No, yeah, I was saying, yeah, but I think some of the states, they are starting to give out some of the permits for like L4. The state of California, I think, gave out permits to some of the Waymo and Cruise cars. So that's kind of where it is.
No,
I just point out the one clearly best thing that governments have done for self-driving in the history of self-driving, and that is the DARPA challenges, right? So the government kicked off this entire industry, right? Now, some ADAS existed before the DARPA challenge, right? But the amount of investment, the amount of creativity, the amount of energy, the amount of excitement for this technology and its ability to save lives and give accessibility and all this fun stuff was really kicked off by the DARPA challenges. And I think this is a great model for how the government can use their leverage, right, in small ways to influence technology for the better.
Well, I also think that government's influence can also be by taking a sane look at what we require and where we're going, and not being too heavy-handed in creating legislation that is restrictive that will slow the pace down. And yes, there is always a risk that goes with it. And the thing you were talking about, China and Japan, I believe that when it comes to the widespread rollout of level 4 and specifically level 5, I think we're going to see China being the first to actually do it. You know, we've got a population that are less risk averse, and you've got a government that can move very, very quickly. So I think they are going to be the first nation, the first region that will roll this out en masse.
Can I just say, I think I think you're quite probably right, to be honest, Peter, but I think in the Western world at the moment, legislation is only half of the problem. I think the bigger challenge may be convincing insurance companies that they can actually cover the insurance for these vehicles. But I think that we're as consumers are really going to struggle to be able to afford perhaps the initial outlay of the insurance companies taking small steps towards, accepting the technology.
Yeah, and also may include issues for business, like even insurance companies, like how are they going to adjust their policies? Like if
Exactly.
who would be responsible if there is an accident that involved an ADAS technology, the driver or the manufacturer? So,
well, what about when the accident happens at the handover point, where the vehicle says, "Well, I can't handle this situation. Now, Mr. Human Being, you need to take it over." But Mr. Human Being has got 2 seconds.
Yeah.
Still, so he's stuck in the middle of nowhere. Who is responsible for that?
The proverbial, it wasn't me.
That wasn't me.
This would be a really fascinating conversation, I think, particularly the insurance, because it talks about who's at risk. And this will probably largely depend on exactly how it evolves, the way Peter was talking, right? If these are personally owned vehicles, then you need insurance. But if these are robotaxi fleets, this probably looks like self-insurance, right? If you own 100,000 vehicles, right, this probably doesn't look like you buy a new insurance plan for each of them. But you can amortize that risk internally. At some point, though, this conversation gets a little laborious, just because self-driving technology alone, without a safety driver, is not yet safer than a human. And so the whole discussion about how do we convince people that it is safe is just premature, right? Well, let's not convince people of something that isn't true until it is true.
Yeah, good point. Yeah. Now let's move on. We have a few less than 10 minutes in our discussion, and I would like us to talk about the future, what the future of ADAS looks like, and the technologies involved in it. And I want to start with a question to Matt about artificial intelligence and the role that artificial intelligence is having in ADAS. So what is your opinion there, Matthew?
Well, I think that personally, software is holding people back. I think a large part of it is the testing that can be done, because as every sort of ADAS level increases, so does the use cases surrounding it. And, artificial intelligence, whilst the promise is very great, there is a limitation. It's not, it's not magic. It's not, robots, fighting wars for us and things like that. Not yet. One of the problems that I can foresee, is at the moment we have, malware and viruses, etc. And I think that certainly for road sign detection and things like that, it is possible that this sort of thing could be used in a sort of nefarious way, and actually cause problems for manufacturers and things like that whose vehicles are out there in the consumer's hands. But having said that, every step forward is a big step forward at the moment. So it's a bit unclear, if the truth be told.
That's good. Yeah, go ahead. Sorry.
No.
If I just think about what Elon Musk is saying about a visually orientated system, I mean, he's relying virtually almost 100% on self-learning neural AI to drive his system. And I mean, his context is, up until now, if you just look at how nature has evolved, if you look at a fish eagle can take a fish out with an area of parallax, out of water perfectly. The brain can actually, take the trajectories, do the calculation and act perfectly. In order to do that, you need artificial intelligence if you're going to rely on your camera. I can't see you can do it any other way. And what you're saying then, Matt, is, there's a lot of work still to be done.
Yeah, and these things can be fooled. We have yet to see any, malware, as it were, against the systems. There's no one's decided that they want to take things down by making road signs that aren't detectable or detectable as something else. And you only have to look online at some of the pictures of misrepresented road signs, and they look almost identical. It's a few pixels wrong in computer vision shot, and it can completely misdetect it. And I'm not sure how that could be, that problem can be solved at the moment, because it's a problem that we haven't even begun to encounter.
Piggybacking off of what Matt's saying about validating is really important. It's surprisingly difficult. Modern artificial intelligence suffers from bad branding. It is not very intelligent. If I were to name it, I would name it something more like artificial pattern matching, right? And this means two things for the data testing side. One is that I'll give you an example. When I want to teach my daughter how to cross the road, I walk her to the crosswalk and I say red means stop, green means go, and then we're just done, right? She gets it for the rest of her life. When I do this with artificial intelligence, I have to give it a million examples of what a green light looks like and what a red light looks like. And it may still run into a red or green light that it hasn't seen before and be confused. So because it's just pattern matching, right? It's just matching to what it's seen before.
Absolutely. The amount of data involved. Sorry, Warren.
No, you're right. You're right. Yeah, this is great. And the other side that Matt is pointing out is absolutely correct as well. And that is, even though it's really inefficient at learning, because it is learning, that means that at some level we don't fully grasp its behavior in all scenarios. And this means that it has to be validated statistically, right? And validating something statistically, especially with lots of nines on it, right, requires an incredible amount of data, right? Depending on what assumptions you're using, right? This is certainly in the millions of miles, right? You could put in reasonable assumptions that say billions of miles, right, are necessary for appropriate testing. And so there's a lot of innovation that has to happen between collecting those miles. How do we use simulation appropriately, right? How do we use the right statistical or actuarial approaches, right, to ensure that we're both allowing the technology to be released in a timely way so that it can save lives and buy back our time, but also also not so premature, right, that it has the exact opposite intended consequence.
No, that's all very interesting. We have barely 3 minutes left. So, Warren, I would like to start with you quickly to tell me how do you think, totally 10, 15 seconds, the future will look like for ADAS, like in the next 5 years, 5 to 10 years?
Yeah, so predictions in this market are notoriously bad, right? So I'm not going to make one, but what I will say is that we have a choice in how we allocate our resources, right? We can, and we live in a world right now where perception and AI is way better than we should have expected in 2015, right? The progress we made there on the perception side is enormous, right?
Right.
And so you see some players, for example, okay, well, it turns out motion planning is harder than we thought, right? So let's go do highways where perception is harder, but motion planning is easier, right?
Right.
And there's the software and the hardware components, right, which really will determine a path forward. I don't know exactly which path is going to go forward, which one will win out, but it's going to be a real fun thing to watch, and whichever way it goes will be a benefit to all of us.
Thank you. What about you, Matthew?
I think it really depends on the amount of processing power that we can get into control systems. That's the real key, I think, at the moment, as well as acceptance by insurance companies and the consumer. And at the moment, it really is a crossroads. I think it could go very much one of two ways. Either nobody accepts it and, things move slowly, or I think Peter said somewhere like China makes a big leap forwards, and all of a sudden, we're talking about old news and everyone's doing it.
Right. Okay, that's good. Let's see what happened. Nathan, what about you?
Yeah, I think if you look at the overall interest for ADAS and looking ahead, so I think consumers see value in ADAS features, and I think EV manufacturers have accelerated the trend. There's high interest in highway hands-free driving, for example, but I think cost is still to hold up with some of the sensors that we have. But then I think I expect to see increase in L2 usage and then L3 from 2023 and then L4 after 25. So that's kind of what I think.
Yeah. Perfect. Thank you. And Peter?
Okay. Well, I think it's a partnership. I think, I believe the end goal is going to be fully self-driving autonomous vehicles. I'm not going to hazard a guess, but the partnership is going to be it's going to be a push-pull between regulation, the technology of the maturity of the technology, and thirdly, the will of the customer to actually accept it and engage it and buy the vehicles.
Fantastic. Well, time is over for the roundtable. We appreciate your ideas, experiences. We are going to not pass it to Katie, who's going to receive questions from the audience, and then we're going to move on later to a Q&A session. So hold in there, and we'll move to the Q&A session.
Gentlemen, thank you all for that great discussion. As Edgar mentioned, we are going to move into the question and answer session. If you have a question for us today, please go ahead and enter it into the Q&A window and hit submit. We will get to as many questions as we can today. If we do not have time for your question, do not worry. We will reach out to you following today's session. So Edgar, I'm going to pass things back to you and the group to answer some of our attendees' questions.
So we are back, and we are having some questions from the audience, some very interesting questions. So this one, I believe, is for Matthew. It says how simulations play a good role, an important role in software development for autonomous vehicles and ADAS.
Yeah, okay. So one of the big features of ADAS is this leveraging of artificial intelligence and the ability of a controller to sort of remove decision making from the driver and take ownership of that. But one of the big problems of this is the sheer amount of data that's required to make sure that every use case is validated and the consumer has confidence that all the testing has been done that should be done and the system is safe. And in order to do that, you can actually use artificial intelligence to almost validate itself in so much as use cases can be generated in a simulation type environment. And this can then be used in what's called a model in the loop, as opposed to actual hardware and driver. A model or software in the loop will be used and simulation environments created which sort of test the controller itself and its behavior in each given scenario, which removes the necessity for all of these validation miles that previously in yesteryear would have been required to make sure that each safety case is adequately validated and signed off.
Oh, so it does help to improve, to speed up the process and make it safer.
Absolutely, yeah, because one of the big problems with collecting a lot of data is how do you transfer it and how do you store it? Right. You're talking about terabytes of data just for one validation test, and moving that sort of thing between engineers, between systems, etc., in itself is a big problem.
Right. So, okay, well, thank you very much, Matthew. Now I have another question. They're coming actually from the audience. It says, where is the debate on camera-only sensing versus cameras on LiDAR and radar? And that goes for you, Nathan.
Yeah, so I think if camera systems can be the backbone of an autonomous vehicle, but I feel that you need truly redundant systems. So you need redundant radar LiDAR subsystem. So a lot of the players have combined systems that combine data from camera, radar, and LiDAR, whereas other players have completely redundant systems where they use camera and then verify the data using radar, LiDAR. So that's where I see. So I see all of those technologies working together. Yeah.
Great, thank you.
Maybe I could just add on top of that just a little.
Sure, yeah. Go ahead.
Great answers from Ethan. Cameras struggle because they have to turn this 2D image into a 3D representation of the world. And the reality is that modern machine learning is just not reliable enough at performing that function in order to operate alone. I think we're all seeing a very public product right now that is camera only. And this is being done by a team of brilliant, hardworking people who are well funded, have tons of data, and even custom computers. I think that represents kind of the pinnacle of what AI can do today with camera alone. And so, just speaking to Nathan, right, that reliability, that march of nines really does come from a redundancy of systems and a redundancy of systems that have overlapping capabilities, not just orthogonal ones.
Right. Well, thank you. Now, there is one very interesting question that just came, and it has to deal with the ADAS stagnation. Like how easy or difficult would be for previous ADAS to be upgraded to a higher version of ADAS. So I think Nathan and Peter, if you can help us on that question.
Yeah, go ahead, Peter. You want to take that first? Or?
Okay. Well, I think as costs come down, sensor costs come down, I think a lot of vehicles, we'll see more and more vehicles actually leaving the end of the production line with a sensor suite already built in, with over-the-air updates possible. And I think it'll just be a software update to bring it up to the next level, which also ties in a bit to what our earlier discussion was around artificial intelligence, about coding. So I think the vehicles will leave and they will be updatable to a point. So whether you're ever going to be able to take a level 1 vehicle to a level 3 or a level 3 vehicle to a level 5, there may be some hardware or firmware updates that might be required to take it there, but generally I think they will be able to.
Yeah, I think I agree with Peter. So I think if you're looking at level 2 plus, so the hardware comes built into the cars, and then its software is updated over the air to turn on certain features. But then, of course, if you go higher up in the levels in autonomy, then I guess you need to add more hardware or sensing on the vehicle.
Warren, that's really interesting. Now, there's a question that I believe is for you, Warren. It has to do with the specification for LiDAR sensors. What are those minimum specifications for an autonomous, a vehicle to be considered truly autonomous?
Yeah, this is a good question. And it's difficult to put a real hard, firm line, because as has been stated many times before, we drive with cameras only. And so the theoretical limit on information in order to drive safely is sufficient with cameras. Now, the real question, though, is given the current state of our AI, right, what is necessary? And when we're thinking about self-driving and we're thinking about that march of nines, I think we're really trying to figure out guarantees, right? Under what conditions can I offer safety guarantees? And so here, the way to really map it is, what is the smallest object that you don't want to hit, right? And then you want sufficient LiDAR points on that object at the range that you need to slow down and stop for, right? And you really want this in LiDAR because LiDAR directly measures geometry, right? Where a camera because it's just doing pattern matching, has to have seen that object previously. The LiDAR can reason about it purely geometrically, and you can say things like, never drive into anything larger than 10 centimeters, which is quite small. And so what you need to do is you need to take your max range, which looks something like 100, 150 meters at a minimum in order to be able to go from a high speed to a stopping distance. And then you need to say, hey, I'm going to need at least 5, 6, 8 pixels on a thing in order to detect it. And this will depend a little on the software team. But it comes in right around 0.02 degrees, right? And then in order to cover the entire field of view, you're talking about millions of points per second. And that's only if you have intelligent foveation. So I don't want to, bore you with the numbers exactly, but it's that kind of reasoning that is necessary in order to offer the kinds of guarantees that I think we need to offer in order to safely deploy self-driving cars.
Perfect. Thank you, Warren. Now I have a few other questions, but I don't think we have time for all of them. So I will have to pick one more. And well, I believe this is a good one. And I think this is for you, Nathan, because it has to do with test and EMIs. So with all those autonomous and connected cars out there, what are the implications to EMI and EMC?
Yeah, I think this is very relevant to Murata as we provide a lot of this EMI suppression components. So I think our automobiles are becoming more connected and reliant on wireless connectivity, and also they have a lot of high compute internal systems, and that may lead to EMI, and the consequence of that can be fatal. So I think it's very important to design to suppress some of this EMI, EMC concerns when you're designing the hardware for an autonomous vehicle.
So Murad is already thinking about that.
Oh yeah, we've been working on this for a number of years, or actually decades. In the IoT space as well. So
perfect. Well, that concludes our webinar for today. Our panel discussion. For today. Thank you very much to all of you for being here and for sharing your experiences, ideas, and opinions with the audience. We appreciate our audience too for being here with us, and we hope that you can join us in the other panel discussions that we will have around this topic. We also gratefully acknowledge Murata for their team of innovators that are focused on facilitating a brand new era in mobility. And finally, for Globalspec.com, thank you for the million of engineers who have allowed us to connect them with parts and services they need for project success. So with that, I will pass it to Katie. Thank you.
All right, thank you, Edgar. Now, just a few more items before we end things today. I would like to say a huge thank you to all of our panelists today and to Edgar for leading our discussion. And a special thank you to Murata for sponsoring our Automotive Electronics Roundtable series. Today was session 1 of our 4-part series. Please join us for the rest of our sessions. You can visit our series page using the link listed in the resource widget. You can use that link right now to sign up for all of our sessions. And one last thank you to our audience members for being here with all of us today. You will be receiving an email from us with a link to the on-demand version of this presentation. You will be able to come back and watch this again or even share it with colleagues. Again, thank you for taking the time to attend this Globalspec series event. Take care, and we will speak with you soon.